All right, today we're going to take a look at the introspective sort. Introspective sort is a hybrid sorting method that uses the best of the quick sort method um, and the heap sort method. Now the problem with just using quicksort is that once the recursion level reaches a certain depth, it tends closer to closer big O of n squared time complexity. However, what we can do is at a certain depth, we can switch over to heap sort, whose worst case time complexity is n log n, which of course is much, much better than n squared. So let's go ahead and go through the methods. Now the main method is just a call on the quicksort. What it does is if the array is empty, basically it's already sorted, so it returns the array. Plus if the array is empty and we try to do the introspective sort on an empty array, you'll find that there's a problem when we try to find n log n of the empty array size. Or I'm sorry, not n log n, the depth limit of the array size, which what we're doing basically then is finding the change of base formula for this, and so we start reaching toward an undefined dividend if we try to do that. So again, if the array is empty, we just go ahead and return that empty array. If the array is not empty, then we find, or we set our depth limit, that's the overall depth that we want the recursion of quicksort to do, by setting that to 2 times the floor value of log base 2 of the array size. Now, since we have to deal with log base 2, I use the change of base formula. So the change of base formula is basically log base n of x is the same thing as log base 10 of x divided by log base 10 of n. So that's the formula that I'm using here. And then again, I find the floor of that because we'll be using subtraction to get to the depth floor, and we want it to be a round number. After we set the depth limit, then we quick sort the array. Now again, this is a modified quicksort that's only going to recurse up to the depth limit. Okay, so again, we talked about that quicksort, and once it reaches, or if the array length is less than or equal to 1, we return the array. However, if the depth limit reaches 0, then we are going to start the heap sort of that array. Again, so again, this is just a basic quicksort method. The pivot's chosen by a random number between the array size. It's deleted at, and then we find the left and right partitions using the built-in partitions method, and then we just concatenate the array by quicksorting the left and the right recursively. Okay, so once we get to that heap sort, then we are just going to use a basic heap sort method. We are going to heapify, or build the heap. This is a max heap. Then we're going to just start swapping the values in the max heap, rebuilding the heap, and then we will return the sorted array. The build heap is just the heapify method and builds that max heap, and the swap is the swapping from the greatest value, or the first method value to the last value to make sure it's in ascending sorted order. All right, so let's go ahead and run that method real fast. Okay, so you'll notice that if the program is the main, then I create a shuffled array of 10 values between -100 and +100. We're going to print the shuffled array to the console, and then we're going to return the sorted array. So let's go ahead and do that. You can see my random values here, and then the returned sorted array. Let's finally run the RSpec. As you can see, 7 examples, 0 failures, and that's it. If you have any questions or comments, please post them in the forum, and I will answer them as soon as possible. Thank you.